Okay, let's make a start. Welcome to the June meeting of the Mornington Peninsula Astronomical Society, and as usual go quickly through a couple of things that have happened in the last month. I think that one might be picking me up doubly. We'll begin first of all with the top right hand side, given that we had Stephen Slater here speaking about Apollo 8 earlier in the year, and of course one of the astronauts, Bill Anders, died in a plane crash recently. He was one of the 3 astronauts aboard Apollo 8 that went around the moon, and I'll play a couple of minutes where NASA put together a memorial for him.
The youngest Apollo 8 crew member, lunar module pilot William Anders, 35, was a space rookie until this flight. He's a major in the Air Force and also a graduate of Annapolis. In addition, he has a master's degree in nuclear engineering.
We have commit. We have liftoff. Liftoff at 7:51.
We went into the shadow of the moon, where we were both in the shadow of the moon from the sun and the shadow of the moon from Earthshine, and it was dark. There were stars everywhere. You couldn't tell which ones they were. There were so many. And I remember looking back and seeing all these stars, and suddenly there was this big black hole. And I got to tell you, the hair went up on the back of my neck, because that was the moon. We were busy shooting pictures of the lunar surface for geologic analysis, but mainly for taking pictures of lunar landing sites for upcoming lunar landings. And then suddenly I looked out the window, and here was this gorgeous orb coming up.
Oh my God, look at that picture over there. There's the Earth coming up. Wow, isn't that pretty? You got a color film, Jim? Yeah, I'm looking for one. C368. Anything, quick. Here. Oh, that's a beautiful shot.
For me, it made me realize that the Earth was small, delicate, and not the center of the universe. Well, I made the comment somewhere along the line that we went to the moon to explore the moon. What we really did was just discover the Earth. And it didn't really sink in on me for a while, but others picked it up. It sort of gave a kickstart to the environmental movement, and so I think Earthrise will go down in history as an iconic first real view of our home planet, which is very fragile and very delicate.
I think I must have the feeling that the travelers in the old sailing ships used to have. We're going on a very long voyage away from home, and now we're headed back, and I have that feeling of being proud of the trip, but still happy to be going back home and back to our home port.
And aside from Bill Anderson passing, we also had an amateur astronomer that was known on TV, Greg Quick from Broome in Western Australia, passed away. He sort of came to fame with one of Brian Cox's space series on TV, where Brian Cox sort of dubbed him Astro Gandalf, which you'll notice there from his beard how he actually got that nickname. I think it was due to cancer, although I might be mistaken. So he passed away quite early at the age of 62. And the two images on the centre of the screen there an announcement that was actually only came out yesterday of a galaxy in Virgo, 300 million light years away, with the rather interesting title of SDSS 13335 plus 0728. In other words, that shows the declination and the right ascension of its location in the sky. So that's why it's these very, very strange names. And it's unusual in the sense that it was a very insignificant galaxy until all of a sudden a supermassive black hole in its centre decided to become active. And in 2019 it went from really, really faint galaxy to starting to get brighter and brighter and brighter. And these things have been observed in supermassive black holes before, whereby they're gobbling up another star that goes nearby with its solar system, but that usually is over and done with in a matter of days or at most weeks. Whereas in this case, this particular supergiant black hole has been brightening since 2019 and is still brightening. So it's been going for, getting on for what, 5 years now. And they think it's either a phenomenon that we've not encountered before with black holes, or something where we're just simply not understanding what is going on there with existing knowledge of how they consume the gas in the accretion disk as it falls in. Now what this shows is the top image. I'll just play a video that goes for about a minute or so, and these are actually real sky images that have been stitched together from multiple telescopes from the European Southern Observatory, so that's the one in South America, and they'll zoom in on the location of this particular galaxy, and then I'll show about 20 seconds in the lower frame whereby they're sort of simulating what is going on, even though they don't really understand what the underlying cause is yet. So this one is about the size of the one that's in the centre of the Milky Way galaxy, the Sagittarius A star. And they don't really call them supermassive black holes until they're at least about 100,000 times the mass of our Sun. So in other words, they've had a chance to gobble up lots and lots of other stars in their lifetime up to that point. Then the lower one, you see it start to brighten there amongst the background stars. And you're starting to see an accretion disk. So they have observed, as I say, these things switch on in the past, but it's usually over and done with, and then they fade back again after a few days, whereas this one has been going for years, which is highly unusual. And lastly, to mention over in the right-hand side that the July meeting, so when we're here next month, is the annual general meeting, and the Secretary will send out a formal notification of that in the next couple of weeks. So just to let you know, if you're interested in coming on to a committee, you can send your nominations into the Secretary. So tonight I'll quickly go through the events of the past month and the coming month. We won't have Astromofo tonight because Chris couldn't be here. However, he said to extend the topic another month. So it's you get one more month to submit any images, and especially at this time of the year, that's probably worthwhile given the cloud and rain likelihood. Then I'll throw over to Guido for Sky for the Month, and then Trevor will talk about his big adventure in Mexico recently, which he survived. And then after a little bit of a break, we'll look at a couple of short videos that go for about 10-12 minutes about the asteroid that wiped out the dinosaurs 65 odd million years ago. Where precisely did it come from? This one tries to actually answer that question, and also looks at some of the effects of the Megatsunami from the impact that would have been generated, and talks about the tsunami. Then at the end we'll actually close with another black hole, and we'll look at the latest NASA supercomputer simulation of flying into a black hole, first of all in orbit around a black hole, and then diving down through the event horizon down to the singularity, what you would see. of course you're not going to survive to be able to come out because it's a one-way trip, but this is actually what the equations tell you will actually happen. So it's quite a mind-bending video if you've not seen that one. So recent events, after the last meeting on the Saturday afterwards, we had a working bee and members barbecue as usual here at the Briars. Then we had a committee meeting via Zoom where we talked about various things to do with the lease and access to the toilets next door at the Echo House, and also the electricity bill that we're getting here at the Briars. So it's surprisingly high considering the number of hours that we're actually here in practice. 24th of May we had one of our SCAG nights, Scout, Cubs and Guides nights. We normally have 3 or 4 of those a year. This was cancelled due to no bookings for that one, so we got a bit of a holiday there. Then a couple of days later we had the Briars Shire staff up here at actually in the observatory for a bit of a viewing night. Unfortunately for them it was mostly cloud. Guido gave the talk, but I think they enjoyed themselves, about 27 odd of them. Then about a week later we had the public night where Trevor gave a talk, and it was completely different, almost no cloud in the sky as well, so they got a good clear night there. And last weekend we had the Cosmology Discovery group up here, and they had a pretty good turnout as well, being 22 turning up on that. So coming soon, first of all I'll mention the observatory sort of shown pictured there. Many of you who've been in the Society a while will probably remember David Girling, who was certainly a vice president for a long period of time, and I think he was president as well for a short period of time, and he passed away a number of years ago. Well, his wife Robin Girling actually has donated his backyard observatory to the Society, so we're in the process of getting that dismantled and moved up here to the Briars. And as you can see, she's cleaned it out especially, and we're just waiting for members to actually go and pull it apart and bring it in, because I think it will require a small truck, and possibly there's access issues with the trees that might have grown up in the meantime since it was put in. So yeah, we look forward to that coming up. I don't think it will be as large and as similar in appearance to the dome observatory that we have out there. It's a different sort of design for that one, and you'll notice by the name of it, it's referred to as a sky shed on the marking on it, rather than necessarily a dome, but we'll see when it comes. Tomorrow night we've got Coringal Primary that's being held at the school. It's pretty close to Ballon Park in Coringal in Frankston. That's the talk will start at 6 o'clock. Yes, we have 300 attendees attending that one. In fact, I think it was in excess of 350, but they put the cap at 300. I went and visited the school and spoke to the organising teacher today for that one. So they got a very long wait list, and as soon as anyone cancels, they go to the next one off the wait list to invite them along. They've been overwhelmed by the response to that one. So that one promises to be a big night tomorrow night, and hopefully the weather plays kind. And if necessary, we'll do the telescopes first if it looks like there's a break in the clouds where we can see the moon, and do the talk second if necessary. So it's a matter of get there around about 6 if you can, even with the telescope, just to be on the safe side. Then the day after, which is Friday, we've got the Echo House next door, bringing some visitors over for a night. They're not having a talk, this is just a quick look through telescopes, so any members who want to help there are welcome to attend as well. We only really need maybe three or four members, and there are 2 that I know about for sure that can make it by 6 o'clock tomorrow, and if any others want to help with the telescopes, that'd be good as well. This Saturday, working bee as usual here at the Briars. Next Tuesday, committee meeting by Zoom, and then the following public stargazing night is on the 5th of July, where Trevor's talking again. And we believe we're going to have a marriage proposal actually on that public viewing night as well. They've actually, the prospective groom has actually approached us to beg for a couple of tickets to come along because he wasn't booked in, and I think it's going to be a bit of a surprise. Now, I don't know whether he plans on standing at the front here and doing it in front of everyone, or whether it's going to be quietly in a dome somewhere. But it could be a very interesting Friday if they do come to that one. Yeah, that's right, yes. Then on the 6th of July, the day after, the cosmology group's having another meeting here at the Briars at 1:45, and members can just turn up for that one. You don't need to pre-announce that you're coming by making any booking or anything like that. Just roll in for that one, and that will go for a couple of hours. Then the following Monday to Friday, we've been advised that there are power disruptions across the Briars for that week. And they're putting in place generators to try and cover things like fridges being off and that. So they're well aware of our requirements up here, and no doubt the other tenants at the Briars are in exactly the same position. Then on the 17th of July, we've got the next monthly meeting up here.
All right, so we've got sky for the month for the rest of this month and then July. So the photo for this month is, as always, the photo from our from Nerida's newsletter, and this was the great aurora we had here. I guess that was already beginning of last month, and that photo was by Ben Claringbold here from the Briars, actually. All right, so just quick look at the solar system. We can see that we are now, well, you can see the Earth down here. We can see that Mercury and Venus are not in a great position to observe. They are basically directly behind the sun from us. And Mars is getting a bit more visible now. We'll see that a little bit later. If we zoom out from there, to look at the outer planets. Again, remember the Earth was somewhere down here, so Saturn now nicely visible, Neptune as well, Jupiter and Uranus a bit more problematic. We'll see that in the all sky picture in a minute. All right, so let's look at the night sky on the 1st of July. So, well, first of all, we'll have the solstice on Friday, 2 days from now. Right, so the winter solstice, so the days will be getting a bit longer from then. We will also have aphelion on the 5th of July as well. So that's for the Earth. And currently sunset is around 5:15 or so. So both Venus and Mercury are very close to the sun. Venus basically not observable at the moment, but Mercury is now past its conjunction and could be viewed around mid-July. And it will actually be, I think, passing through the Beehive cluster on the 7th of July. And then we'll have the full moon on the 22nd of June, so just a few days from now. Then the next new moon on the 6th of July, and then a full moon again on the 21st of July. All right, just in terms of the night sky, you can see Antares in the middle there, and the Scorpion. I think I have the constellations in the next view, as well as the Southern Cross and the 2 pointers around here. So the Milky Way nicely stretched across the entire sky there. So that's really dominating the sky this month. If we look at the constellations, I think on the next one, we have Scorpius and Sagittarius here. So the core of the Milky Way also coming up now, and with all the targets that we can look up there if the clouds actually let us. So if we fast forward a bit through the rest of the night, we can see some of the planets appear. Well, first of all, there's Ceres here, one of the, I think it is the biggest asteroid, so one of the minor planets, and that one's coming up for opposition. I think next month. Greg actually mentions that in an article in the next newsletter, so have a look at that one when it comes out. And Psyche, another asteroid, also observable at the moment. And then we have Saturn and Neptune rising relatively early in the night. I mean, compared to just like a couple of months ago. And then towards the morning, we have Mars, Uranus, and Jupiter rising as well over there. So Mars now rises around 3 a.m. It'll be within 1 degree of Uranus on the 16th of July. So they're getting relatively close around that time. Then we have Saturn rising well before midnight now. Basically beginning its retrograde motion where it appears to go backwards for the next few months on the 1st of July. And it'll definitely be a bit more observable at reasonable hours from later July and then in August. Neptune also rising in the late evening, as you can see, just after Saturn. And then Jupiter rising around 5 a.m. and it'll be near Aldebaran. So that might also be a nice view in the early morning sky. And finally, Uranus is now past its superior conjunction, rising at around 3 a.m. at the moment. And then moving towards the morning, we'll have sunrise around 7:15 or 7:30. 7:30, a bit later. And yeah, you can see Venus still very, very close to the sun over there. The apparent sizes of the planets for July, for the ones that are observable, you can see the comparison in sizes here. What you can also notice here is that Saturn's rings are almost edge-on at the moment. And I've actually got an animation here. That's another thing that Greg has in the newsletter for next month. So this is an animation of basically zooming in on Saturn over the course of a few years. So starting from, I think, February 2022 and all the way up to 2027. So you'll see, well, there's all the moons that are racing around Saturn like crazy. So if you just ignore those, what you can see is that there's a little bit of a wobble in the way we can see Saturn from here, which is due to, well, how the axis of both planets align and how we both rotate around or orbit around the sun. And what you'll also see is that the rings start closing up and then opening up a little bit again and then closing up again towards, I think, February and March next year. So I'll just play the animations here. That's the moons running around. But you can see, so this is now mid-2022, August, September 2022, so we can still see the rings kind of from above. You can see how the shadow of the planet kind of switches from the left of the rings to the right and so on across that time. So we're now at the end of 2023, December 2023. You can already see the rings closing up a little bit. And so this is now May, June, so around now. So you can see the rings are almost closed. I think it's only 2 degrees or so. And then they open up a little bit again towards the end of the year. And then for next year, they will actually close up completely where we see them edge on. And then we'll see the underside of the rings, basically, when it turns the other way around. And the reason for that is just that they always point exactly the same way. Like it's the same as the axis of the Earth that always points into the same direction in the sky as both planets orbit around the sun. And so just because of the 2 orbits, how they align, we sometimes are exactly in the plane of the rings and then we see them edge on like that. Unfortunately, when they really edge on next year, the planet won't be in a good position to observe. So it'll be relatively close to the sun, so we won't get a good view. But in July, when they're almost edge on, like only 2 degrees or so, it should be much better. So that should be a nice opportunity in, I think, a couple of weeks or so. Whenever we get a nice clear night, that should be a nice target. All right, comets, we still have Pont Brooks in the sky, setting around 9 p.m. now. I'm not sure if Greg tried to take another image in the last few weeks. All right, so So the ionizing tail is pointing in one direction and the dust tail in the other. All right, interesting. Yeah, but it's now fading. So the projection is that it'll fade from magnitude 9 to 11. So we're getting, getting a little less interesting now. Basically, last chance to see. We've got another few comments in the sky at the moment. 13P Albus, 154P Brewington, and they're all relatively faint. And then C2023A3 is also probably still in the best position for observing, but it's also only magnitude 10 at the moment. That one's brightening. So yeah, we'll have to wait a little bit longer because I think there's 1 or 2 comets coming up later this year that might be more interesting. Meteor showers, we have the Delta Aquarids from the 12th of July to the 23rd of August. So that's almost something for next month's Sky for the Month, but starting on the 12th of July. They're pretty faint, but up to 25 per hour. So they could be good to observe. And the Alpha Capricornids from the 3rd of July to the 15th of August with only 5 per hour, but they can be pretty bright and slow, peaking around the 29th of July. Okay, as always, the sources for this were Stellarium, NASA Eyes on the Solar System, and the Astronomy 2024 yearbook. Thanks. Yes, the Corona Borealis is up here. Right, that's where there's a possibility for a nova later this year. Yep, right. Yes, hopefully we'll get to see that. Yeah, thanks.
Before I introduce Trevor, I forgot to read out the names of the new members that we've had since last meeting as well, which I'll try and read my handwriting in this light level. There's Vivek Sheshadiri and Chitra Brindavanam, Alex Dermatis and family, and Christopher and Veronica Collingwood. So I assume that no one's here tonight of those, and just welcome those as new members. And with that, I'll pass the baton on to Trevor. And the mic. He's been a member of the Society for goodness knows how many years now. Probably 12 at least, maybe even more. Yeah, he's currently on committee and speaks at a lot of the public nights, as well as the odd cruise ship around the world as well. So he's one of their enrichment speakers that he's been doing a very long time doing that as well. So he obviously enjoys it.
I'll be talking about the April the 8th total eclipse. This one, there was absolutely nothing visible in Australia because you had to be at least in North America somewhere to see any of it. So you didn't miss anything if you were in Australia. We went to Mexico. We were actually on a cruise ship to see this. So I'll talk a little bit about why we have eclipses, but particularly this eclipse, which is off the coast of Mexico. Now, quite a few weeks ago, time really does fly when you're having fun. And then I'll talk about some upcoming eclipses, particularly some that are coming up that we can drive to in Australia, namely the one in Sydney. But Sydney, you'll find, is not really the place you want to go. It's around about this time of the year. Sydney is not going to be statistically the place you want to be. Just like Melbourne, if it was here, you wouldn't necessarily want to be here in June. You want to be somewhere else. And there are lots and lots of possibilities where you could go. So why do we have eclipses? Now, you've probably noticed when you look up at the sky that there is a relationship between the two. If we look at the figures of how far the sun is from the Earth and how far the moon is, and divide those two figures, we get a number that's approximately 400. It varies a little bit. If we then look at the diameters of the two objects, of the diameter of the sun versus the sun of the moon, the diameter of the moon, divide those two, we get another number that's about 400. Again, it varies a little bit depending upon the distance. So as seen from the Earth, the two appear to be the same size. They will only be this size for just another few more, I don't know what, several millions of years, but eventually the moon is moving slowly further and further away and getting smaller. So eventually all total eclipses will become annular. So they won't be total. You'll see the moon in the middle of the sun and a ring around it. But I don't think any of us will be around in a few million years to have that problem. So at the moment, it just happens that we are at a particular time in the Earth's history where the two appear to be virtually identical in size, particularly given the right times, where the right distances and the right orientation. So what happens if the moon passes directly in front of the sun at this time? We get a total eclipse of the sun. So the body of the moon just happens to be the right size to cover up the whole of the surface of the sun, and so we can see the perimeter of the sun and the corona, which we can't normally see because the corona is about 1 billion times dimmer than the sun itself. So you just can't see it. And if you were to wear protection so that you can look at the sun, you wouldn't see the corona anyway because you wouldn't see the sun either. So the whole of the surface of the sun is blocked, and any particular place on the Earth that's directly under where the moon's shadow crosses, you will see a total eclipse. Now, we don't see it every time, even though we have the moon circling around the Earth. It doesn't always line up with the sun because it orbits at an angle. So it goes, most of the time it'll travel a little bit above the sun or a little bit below the sun. And we won't see it line up exactly. But it's only when the axis of the rotation of the moon is correct that it will appear to travel directly in front of the sun, and we will get a total eclipse. But you have to be in the right spot at the right time, and as you'll see from some of the figures, it doesn't happen very often in one place. So the last eclipse in Melbourne was October 1976. I remember that. I didn't even have my driver's licence. My experience of that eclipse was my uncle happened to choose to have his marriage, his wedding ceremony down at Colac on the day of the total eclipse. So we had to drive down to Colac, and we were coming back just along the little river exit on the freeway, and it went dark. So my brother turned the headlights on, and then the sun came out, so he turned the headlights off. That's all I got out of the 1976 eclipse. We heard the birds coming in as we were coming back past Geelong. We heard them tweeting and trying to go back to bed, only to be woken up again a couple of minutes later. But that was my very first total eclipse. Headlights on, headlights off, that was it. That's all I got. So this is probably the what they called the Great American Eclipse back in 2017, which is now 7 years ago. And that was in all the newspapers and that at the time. But if you are around, when are the next ones in the later future? In 2038, Boxing Day, there's actually an eclipse. And I don't know anyone around here will be here at 2093, but if they are, there's another one that goes right through Adelaide. Yes? Oh, you'll be there, Fred? Yeah, okay. We'll organise something. We'll leave a stick-it note on the fridge for someone that Fred wants to go to Adelaide, 2093. So when's the next eclipse in Melbourne? It's actually the 4th of April. It's about 5 o'clock in the year 2220. So although they say an eclipse is a once-in-a-lifetime event, it certainly is for the one in Melbourne in 1976. If you don't go somewhere, you won't see another one. Unless you're lucky, America's actually got 2 or 3 that have overlapped just in the last few years, so they've been a little bit greedy, but you'll see that we've actually got some coming up from the Sydney one and onwards. There's quite a few in a relatively short period of time. So the most recent in Australia was off the coast of Australia and went up through Indonesia. That was last year, 20th of April. This particular one, and I know there are some people in the room here that drove all the way to Exmouth and set up all of their equipment. If you look at a map of Australia, there's the tiniest little bit that sticks out, and that's the only bit that you could stand on. All the other bits, you had to be in the water or go all the way up to Indonesia. My wife and I just took a cruise ship from here up to Exmouth. Took a couple of days. They dropped the anchor. Early in the morning we were there, all anchored, stable, beautiful clear skies, as it was for those that were on the coast as well. And when the eclipse was over, they pulled the anchor and they sailed back. So we didn't go anywhere. Yes, Fred?
Sure. I seen an eclipse when I was living in Mornington. That was about 5 years ago. And when it passed about 11 o'clock on the night, it looked like just like a golden ball. What year would that be, 2017? I seen one.
Don't know.
Yeah, I seen one. Yeah.
Yeah, because as far as I know, the last total eclipse around Melbourne area was the 1970 something. Yeah.
I seen one in.
It could be a partial. Yeah.
Eclipse I saw from Sandringham.
Right. Yeah. Because to me, a partial, like if you're trying to head to a total eclipse, say on a ship, and you didn't make it, you might as well have not been on the ship.
This was a very partial one, but
right, yeah.
Set eclipsed.
Yeah.
And it looked like a shark's tooth coming out of it.
Right, yeah. Yeah, because I know there are some people in this room that were heading for another eclipse off in the Pacific, and the captain had the cheek to say, at least we got 99%, which is just like saying you almost got pregnant. No. Not anything less than 100% eclipse. I wouldn't do anything more than drive an hour to see it, because it's just not worth it. But to see the eclipse, yes, it's certainly worth travelling. And particularly like this, we flew all the way over to Perth. We were there for a couple of days, took the cruise, came home, and then we flew home. But it was 58 seconds, also very short. But at least that was the first one I was able to actually see something. So this is a couple of pictures from Sky and Telescope of what the eclipse looked like that we saw last year, which was actually more impressive than the one I saw this year, because you can see there's a lot more activity around the edge of the sun. And that's the one thing I'll never forget. As the sun came across, and I forgot my glasses, so it was a bit out of focus, but I saw this almost iridescent crimson on the edge, something that you just really would never expect to see on the sun, this really, really bright crimson, which I also saw in the one a couple of months ago, but this was far more impressive because you can see there was a lot more activity around the edge of the sun. So unfortunately, there's not really any way to tell whether upcoming eclipses are going to have any activity like this. They may or may not. It's hard to say. Mind you, Solar Max is coming up, so statistically it should be a better chance anyway. So the next one was the 8th of April, Mexico, North America, you had to be. Now this path, as you can see, came across the Pacific, up over the coast of Mexico, went through Mexico, through parts of Texas, and eventually finished up over towards Toronto in Canada. So America had their great one that sort of went the other way in 2017. They've got this one goes this way. So they've actually had a couple. And there was I think an annular eclipse just a year or so earlier than this, and there was a crossover. So there was one place in America where you could actually see an annular eclipse and a total eclipse within a year or so. not even a lifetime event. So this particular one, as I say, the one off the coast of Western Australia was about 58 seconds. This one was 4.5 minutes. So considerably longer. The one off the Western Australia coast was almost like blink and you miss it. This was at least enough time to look around, and I had my glasses on so I could look around and see a few things, take a few photos as well. Now, this is the sort of thing you need really for an eclipse, and I have one for the Sydney one, which is very interesting. But you'll see here, this is the statistical likelihood of cloud cover. I'll try and cover the microphone because I think it's the heater that's making a lot of the muffle. So you can see here where the eclipse starts. It's about 50 to 60% cloud cover, but as it comes in over the Pacific, you get to the coast of Mexico, and this is the coast here. The percentage cloud cover is around about 25%. Then as it goes through the coastline of Mexico and heads across, so you're heading along this way, it gets statistically more and more likely to be cloudy until you get up somewhere around here. This is Quebec, so this is Canada, so you're up around here somewhere. You can see 85% likelihood. I saw a few photos that some people that were in Toronto put up, and it was 100% cloud. It just went dark. That's all they got, because they were up somewhere around here where the percentage likelihood was very high, and in fact it was 100%. They couldn't see anything. Texas, I believe, down around here, there was some members, I believe, that went to Texas and they could see something of the eclipse. But we were on a cruise ship just off the edge of Mexico. The possibility was 25%. It was actually probably about 5% cloud. There was no cloud you could see except in the distance. So it was virtually perfect conditions, and it was warm, like 35 degrees, unlike what we're getting in Melbourne at the moment. So the coast of Mexico is the place to be, and you also get a cruise fitted in at the same time. Now, there was a number of the cruise lines. Holland America and Princess in particular had two cruise ships each that would take in this particular eclipse. This particular one here was always intended for the eclipse. It booked out like a year and a half, 2 years in advance. So then they discovered that there was another cruise, the Emerald, which by changing just a very small change to the itinerary, they could be in the spot for the total eclipse by just making a small change of the ports and then run the rest of the cruise. So that cruise then very quickly filled up because the people that couldn't get on this one came across to this. Holland America, this one was run with Sky and Telescope, and this was just a normal cruise, went out from San Diego, they got the eclipse here and it went to Hawaii and back. So that was a very long cruise, 22 days, a lot more expensive. This particular one was interesting. If you wanted to go to talks on this cruise, is something like $2,000 to register US to go to the talks that they would have. They had some fairly well-known astronomers on there talking about astronomy, various subjects, but it was something like $2,000 US if you wanted to go to the talks. They weren't included in the cruise. This particular one that I was on, they had one enrichment speaker and it was included. So you didn't have to pay thousands of dollars to go to the talks. And of course there were lots of people on this ship, and I believe they did the same thing on this one as well, on the Discovery. There were lots of people on there, of course, that were interested in astronomy, and they had, some days they had 4 talks on at the same day. The astronomy guy a couple of times did 2 talks. They had night viewing every night if it was clear. They had other enrichment speakers talking about various other subjects as well, but lots and lots of astronomy-related things. So anyway, we decided we would take this particular one and we'd fit it in as a holiday. So we were on the Emerald Princess. So we flew to LA a few days earlier. We did the usual touristy stuff. We've been to Hollywood before, but we did the usual tour up through the Hollywood Hills and take the photo of the Hollywood sign. Of course, the Walk of Fame. You've got to do that when you're in Hollywood. We also even caught the Bruce Springsteen concert. He was supposed to be giving a concert the week after, so we would have been on the ship, but it was cancelled and rebooked a week earlier. So we discovered only about 4 days before we left home that his concert had been changed to the evening before we got on the ship. So my wife got on the computer on Ticket Tech, got two tickets with 2 people in between us. And we thought that was the best we could get, but we thought what we'll do is we'll sit down and go, can you just pass this together? Yeah, just a second, I'll pass it over to you. And we thought, and then we would easily get the seats together, but by the time I was shuffling across, my wife had already convinced the couple to move across, and we actually had 2 seats next to each other. So we were able to catch the Bruce Springsteen concert. After about 3.5 hours, we got our driver to wait out the front to pick us up, because he's renowned for going an hour and a half overtime, and you don't want to be trying to find your pickup when all these people want to go home. So we walked out and there were hundreds of people already left, and the concert went for at least 3/4 of an hour after we left. Found our driver and he took us back. So we didn't have to deal with tens of thousands of people trying to get out. You could use public transport, but we were told this is not the area you want to walk around at night. So we booked the driver, and he actually also picked us up and took us to the ship the next morning. So that was something different. We stayed at this B&B. It's about 200 metres from the Hollywood Walk of Fame. Very, very close. We tried to book a hotel. Everything was booked out. I don't know what was on. Everything was booked out. I zoomed out on booking.com and I saw this place that was half the price of any hotels. And I had a look at it, and it's a little B&B, and it's just a little house. She's got 3 bedrooms that she rents. And so we took the last available bedroom and we stayed there so we could walk into Hollywood. It would take us about 10 minutes and we'd be right on the Walk of Fame outside the Chinese Theatre. So excellent place to stay if you don't want to stay in a hotel, and a lot cheaper. So we boarded the ship and we headed south. This is down off the coast of Mexico. I think this is probably one of the myriad of volcanoes or something like that just on the horizon. Now, as I said, they had enrichment talks every sea day. So if there wasn't a port, there would be a talk, one on wildlife, one on astronomy, one on the ports that you're going to. There's another guy that gave various talks on other things, photography and stuff like that. So there were heaps of activities. As you can see, the theatre was very packed. This holds somewhere around about 1,000 people. So there were people actually standing at the back. So there was probably about 1,100 to 1,200 people at most of the talks. Again, because it's about astronomy, and there were lots of people on the cruise that were interested in astronomy. So a little bit of a captive sort of an audience, if you like. So he talked about wasn't always in the same venue. This one was a little bit too small. He had far too many people for the size venue they put him in. But he talked about the moon, another one about telescopes, another one about Mars. He talked about Saturn and all this sort of stuff. But the one thing that I found most interesting, Americans like hyperbole. They were like, wow, with his talks. And at the end of a talk, I don't think anyone learned anything because it was all hyperbole. So this is an example, and it's really good because it's got the audio. Try again. Huh?
The arm that is seen in the picture. And if you're into the romantic aspect of space exploration, that's sunset on another planet. Whoa. And if you're into the big picture, who remembers Alan Funt? Smile, you're on candid camera. Right there, that little dot is all 8 billion of us on this itty-bitty, little, teeny-tiny blue dot seen from the surface of another planet.
So I say all of his talks were all hyperbole. It was all, this is the most significant invention in the history of mankind. This allows us to measure things that we would never have dreamt of in our life. But he never talked about why it was. Why was the spectroscope such a great invention? The most important thing in the history of mankind was the spectroscope. Why? He didn't say. It just was. Because with planets around other stars, we can measure the atmospheres and we can measure all these characteristics. But he didn't say anything about why it was important. It just was. And all of his talks were just pictures, and pictures like he talked about telescopes. Here's a picture of the Keck. Here's a picture of Mount Palomar. Here's a picture of Hubble. Here's a picture of this. And? So he was a nice enough sort of a guy, but yeah, he was very hyperbole. But I think it's because that's what the Americans like. Right, so this will probably play again if I go to the next one. No, stop that. I've got my glasses on, I can't see the keyboard. Right. So the very first port was in Cabo San Lucas, which is very, very popular if you do any cruises down Mexico. So we did a day trip down there, and we actually saw some whales. We were disappointed when we booked it because when we got onto the Zodiacs, they said, unfortunately, most of the whales have gone home. And we thought, ugh. But we saw about 20 or 30 whales. They had a hydrophone that they put down to the water, and we could hear the whales singing away. You could hear, whoa, 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 all this sort of stuff. So that was something different, and particularly when we thought we won't see anything. We didn't see any of them come up like on the movies and Breach, but they came up like here, and you could see their flukes and all that. So that was a bit of a highlight, particularly for the first port. The next morning, we were off the coast of Mexico, ready for the total eclipse. This is the Discovery Princess, which was the original Princess cruise that was going to the eclipse. And we're on the Emerald, so you can see they're relatively close to each other. So this is Cruise Mapper. You can see here's the Emerald, there's the Discovery, the Zaandam and the Koningsdam were nearby. There was another small ship in here which didn't come up on this resolution on the map. And then way down here was another one, was the Swan Hellenic or something, a very expensive expedition type cruise. So there was at least 6 cruise ships. We didn't really think about the Swan Hellenic because it would have cost $10,000 at least for the cruise, let alone everything else, compared to just a couple of thousand for what we did. It was interesting actually, when we were in Cabo, there was another cruise ship there, 6-star luxury. They were paying 3 times at least what we were paying, and they were right where we were, exactly the same spot. And then I looked after we'd sort of set sail, and they were heading north. So the people on this very, very expensive luxury cruise paid a lot of money to not see the eclipse. They were within hours of sailing to see it, but their ship was heading back up towards Los Angeles when there was a total eclipse. So I'm sure their captain would have said, at least we saw 70% and you paid $1,000 a day to not see a total eclipse. So obviously they hadn't planned ahead because they could easily have changed that cruise to go to the total eclipse, and they didn't. So obviously some companies just aren't switched on when it comes to stuff like this. So there's several criteria when you're on a cruise ship that are not really applicable when you're on land, because of course a cruise ship moves. When you're on land, you set up, boom, there you are. So the first thing is the ship needs to be still. You want to try and keep it steady. They have to point it towards the waves so it doesn't move too much. But also when they anchor, it has to not turn. Because if you set your telescopes and cameras up and there's the sun and you're about to get the eclipse and the ship moves, you've now got to move the telescope back, and as the eclipse sort of moves across, and if the ship continues to turn, you've lost it. So they have to make sure that they keep the ship anchored and that it doesn't move around very much at all. In this case, and the one off the coast of Western Australia, it was almost as stable as land. It moved a little bit, but it did not turn. So once you set your equipment up, it still pointed at the sun. You just had to track it. Smoke from the engine room. They need to orient the ship so that the prevailing wind moves the smoke away from the sun. It's all very well to have the ship stable, but if the sun's here and the smoke is streaming right across it, most of the people on the ship will have the smoke, which is not too bad, but they would have smoke over the surface of the corona. So that would definitely impact on the quality of your viewing. So the smoke wasn't a problem. I didn't see any smoke drifting across where the sun was. It was almost directly above. So it was in a very good position, like Western Australia as well. It needs, as I said, it needs to not turn or drift. You don't want it to still keep moving. It has to be stable. So it remained quite stationary where it was for the whole duration. There's also limited places to set up on a cruise ship. So to make more room, they picked up most of the deck chairs that would normally take up this much room, where 6 or 8 people could stand. They packed those up to make room for people that they could set up their equipment, etc. So that wasn't a problem either. There was plenty of room, as you'll see in a couple of my photos later, for 3,500 people and 1,000 crew. So 4 to 4,500 people on a ship that normally a lot of them would be inside, would be outside. So that wasn't a problem. So as the sun nears totality, it's interesting because people had, I had solar binoculars, so you could look a little bit closer at the sun, 7 times magnification. And as it gets closer to totality, you could say to people, oh, do you want to have a look at the binoculars? Oh, yeah. And then once it reaches totality and it's going the other way, so it looks much the same, you say, oh, would you like to have a look? No, I'm not interested. But it's a 99.9% total eclipse. It's almost total. They would love to see it before then, even when it's 80%. And now because it's gone past 100 and it's now only 99%, no one's interested. You'd see people there staring at the sun as it's like 20%, 40%. And then when it's over, oh, it's 99%. Oh, we'd better go get a cup of coffee. So no one was interested in the stages after totality, even if the sun is more extreme covered than this, which is very interesting. Same thing happened in Western Australia. Once it was over, people weren't interested in a 99% eclipse. In fact, on the Western Australia cruise, I'll never forget this, there was one person had gone down to the coffee shop below to get a cup of coffee, and they said there were 2 people sitting there in the coffee shop reading a book with their back against the window, reading, while it's like 92% total eclipse. They're reading a book rather than being out there looking at it. I'm sure when it went to 100, they probably went, who's turned the lights out? Oh, I can see there. They probably just, whoosh. Some people were on both of the ships that we were on. They knew nothing about the eclipse at all. They booked it for other reasons. Some weren't even interested in the eclipse. They just happened to be there, didn't even bother to look. What a waste. So as the eclipse draws closer, and you can see there's quite a bit of room, a lot of people would set themselves up on the edge here to leave room so people can walk past throughout the ship without tripping over tripods and camera setups and all that. So the sun was sort of up here at its peak, as you can tell. The shadows are quite short, so it's pretty close to midday. It's about 11 o'clock or something, I think. And as the eclipse gets closer to full, one thing you notice is the light goes funny. It's, for those that have been at a total eclipse, it's hard to describe how it is, but everything looks funny, like really, really sharp, but unusually so. The colours are just a little bit muted, a little bit unusual. The lighting, the focus of everything is just sort of weird. Of course, being on a ship, you don't hear the birds come in to go to bed, but there are actually some scientists wanted people to observe animal behaviour, like particularly dolphins, during the eclipse. So rather than looking at the eclipse, they wanted people, particularly on this ship, to see if there were any dolphins around, what the dolphins were doing as it went total. And there were people actually doing that, looking for dolphins during the total eclipse and not looking at the total eclipse. Because people hadn't done that. They don't know what these animals would do. The birds sort of go to bed, but what do sea animals do? It's getting near night time. Do they go to sleep, or what do? Do they act funny? So I haven't heard anything about what that study has shown, but there were people on the ship that were there looking for dolphins, and we did see dolphins and flying fish and all that stuff as well. So they had these solar glasses for everyone on the ship, and also the crew. So you'll see there's a lot of crew out here. We took, rather than these glasses, we had the ones that we got from Western Australia, which are actually on a lanyard. And rather than glasses that you had to put around your head, you could hold that up, and when it's total, just drop it. If you've got glasses and you drop it, particularly on a ship, it can blow away. It can blow into the ocean. So where do you put it? And by the time you sort of find somewhere to put it, you've missed out on some of the eclipse. But with these, it just let it go. So we'll probably take those with us for our next eclipse as well. So it was a very, very handy idea. They were from Sky and Telescope. They provided those. And the other ones, I think they were just NASA certified one. But they bought probably 4,000 pairs just for that ship alone. Now the enrichment speaker was there standing next to me. He was in his Aruba from the Caribbean, or Caribbean I should say, watching the total eclipse. I had my little card with me instead, so I could just drop it. Then as the totality approached, you can see it was actually relatively clear. There was a bit of cloud, scattered cloud down low, but where the sun was, which is quite high up, absolutely perfectly clear. There is no interference whatsoever from the clouds. You can see now it's getting closer to totality. It actually got quite dark. Nothing like nighttime, but quite dark. The shadow on this was relatively wide. The one in Western Australia was quite narrow, so when you looked out at the horizon, it's daylight. So you're standing here and it's quite dull, and you look out there and it's fully daylight because the shadow was quite narrow. This one, the shadow is nearly 200 kilometres across, so you looked out to the horizon and it was dark. Not to the point where you couldn't see, but it was dark enough that it's like, geez, getting pretty late now, almost like the sun's already set, and of course for only 4 minutes or so. So as it slowly got darker and darker, you'll see the camera, of course, increases the exposure. It's actually much darker than what the camera shows. Now these are just a couple I took with the mobile phone. They're not exactly the best. You really need an SLR. You need full control over the aperture and everything. But you could see Venus and Jupiter with the naked eye with this particular one. There was a thought that you could see the comet, but no, you couldn't see it even with binoculars. So it was a little bit too dull. You could also see Mars and Saturn, and I think Uranus or something, if you knew exactly where to look, but they were all around near the sun and probably would have been visible with a small telescope or something. So here is Jupiter and Venus, easily visible with the naked eye, particularly during totality. As it almost got to totality, you could see Venus beginning to become visible, and then at totality, Jupiter popped out. And if you had binoculars, there's a couple more planets up around this way, and the comet was up here somewhere. So this is a picture. As you can see, there was nowhere near as much activity around the edge, much, much smaller prominences than what there was in the Western Australia one. This is the diamond ring as the sun slowly sort of pops out to the side, and some of the sunlight comes through the valleys on the edge of the moon, creating this effect. Princess took a few promotional pictures, of course, to put on all their brochures, and I'm sure Holland America did the same thing. But one of the passengers actually took probably the best picture of a total eclipse I've seen. A lot of artistic license. He got all the phases of the total eclipse, all in one picture. Right? I couldn't resist when I saw this. I've got to take a grab of that. So someone on Facebook created this with Oreos, and then I suppose they all sort of met with death as their kids probably chewed them all up. So our next stop then was Huatulco in Mexico. So this was then when we were able to sort of get on to our actual holiday. There's our ship in the background. Nice little port, lots of little ships there. Then we went to Punta Arenas in Costa Rica, and it was great. When we were in Costa Rica, the police were always looking after our welfare. They were always there checking Facebook just to make sure that there's no drugs or anything going on. My wife couldn't resist this when all the coppers are just standing there on Facebook instead of protecting people or whatever. Yeah. Then we went through the Panama Canal. Anyone that's interested in technology or whatever, you'll find the Panama Canal is really interesting. This is the new locks. The old locks are similar but much, much narrower. So our ship wouldn't fit through the old locks, so we had to go through the new ones. So you come into here, and the container ship in front of us has already gone through one lock. It sails through. They close the door. The door's already over. Pump this level up to there. Then by then, that ship's gone through. They open the door. We sail through to the next lock. They close the door behind us, pump the water out. Another ship comes in. And so they go through, I think it's 3 locks at each end to slowly get you up to the height of the lake in the middle. So you see these massive doors. They weigh like over 100 tonnes each, and they open at about this speed. So it takes several minutes for it to open, and then you sail into the hole and up you go. So very interesting if you're interested in engineering and the technology of the canal itself. So here we go. We've got the same ship in front of us. We've gone through the lake in the middle, the Gatun Lake, and then this is the last lock before you end up on the other side in the Atlantic. The Pacific is behind us. So here's one of the control towers. Now the control tower actually has a webcam. They have webcams on all of the gates at the Panama, so you just Google Panama Canal webcam and you can see what's happening at the Panama Canal, and if you're going through, you can actually see your own ship go through. When we went through the old locks back in 2018, we were on a cruise, we went the other way, and my wife, it just happened to coincide with a reasonable hour in Melbourne, and she Facebook messaged her daughter in Melbourne who brought up the webcam and could see the front of our ship as we were going through, and we were waving and she could see us waving from Bentley on the webcam going through the Panama Canal on the other side of the world, which is a bit cool for the technology these days. But yeah, you can have a look at these any time to see what ships are going through, particularly if you're interested in the canal as an engineering exercise. Then we went to Cartagena in Colombia. We didn't get any drugs, no. I didn't know Colombia actually is not just known for drugs, it's also known for emeralds. It's like the emerald centre of the world. So we went to Cartagena in Colombia, and when you come back to go onto the ship, it goes through this huge aviary with hundreds of birds, and it's free. You just walk through there in order to get back to the ship. So if you want to see all these different toucans and everything you can possibly imagine, like flamingos and everything, again, great to walk through and see all these different birds, and it's free. And you have to go through it to get to the ship anyway. Then we went to Cayman Islands. took a helicopter flight from there, 20 minutes out over the island, and saw the coral reefs and some of the people off the back of little ships that were doing snorkeling and stuff. Back to Fort Lauderdale, and then we flew back to LA and we were home. So the next eclipse, you'll notice there's none in 2025. 2026 is the next one. You don't always get a total eclipse. You can get a couple of total eclipses in a year, but you don't necessarily get them every time. So the next one isn't until 2026 in August. This goes from Greenland down through Spain. So you can see the shadow here. Now the problem with this is Iceland's quite cloudy. This is sunset. So if you're anywhere around here, the sun will be about here when it's total eclipse. But if you want to see it higher in the sky, you've got to go further up here and be in the middle of the Atlantic. But you'll find when I show you the cloud cover, it's probably likely you won't see anything. You're most likely to see something around here. If you're just off the coast of Spain here, it's about an hour before sunset. So you'll see the total eclipse at about that sort of height. But at least you might see it. If you want to look here, it'll be high, but it'll probably be cloudy. So you look at the this cloud graph, and you want to be in the blue area. So here's Spain. This is the island of Mallorca, so it goes right through Mallorca, right across the middle of Spain here. So you want to be around here. If you go up through here, around by Greenland, you'll see 80 to 90% cloud cover. So this will most likely be clouded out. That's the edge. Reykjavik is around about in here somewhere, and then there's not much in Greenland. Particularly on this side, there's a couple of ports around here, but there's nothing that this really goes over. So Iceland and all through here, there'll probably be cruises, I guess, but very likely you won't see anything. There are cruises that will be off the coast of Mexico. Sky and Telescope is running some groups down through Spain, so if you always wanted to see Spain and a total eclipse, it'll be low on the horizon, like an hour before sunset, but at least that'll be on land, relatively likely to be clear. So that's 2027. You'll see as comes from here, heads down towards Greenland, it clears up a bit, and it gets cloudy as it gets towards Iceland, and then it's only when you hit here, here's Mallorca, 35%, it's only when you're around Spain that it's likely that you might see anything. So not the best destination. I know there's a number of people that were on our cruise are going on one of these, even though it'll be low. I thought, I'm not paying all that money to watch the sunset. Maybe later. So Princess said they'll have at least two. Holland America, I believe, will have a couple. So if you want to do that, yep, you can. But the next one, 2027 August, this is off the coast of Africa and Egypt. If you ever wanted to go to Egypt, the Temple of Luxor is around about here somewhere, about 10 kilometres from the longest period of totality. So a lot of Sky and Telescope are doing, I think, about 6 tours through Egypt, which includes cruises down the Nile, and you can have the total eclipse and you'll be at the Temple of Karnak and all this stuff with the eclipse in the background. So it should be quite high in the sky because the sun sets somewhere way down here somewhere. So there'll be lots of tours going through Egypt. If you ever wanted to see Egypt, if you ever wanted to go to the Rock of Gibraltar, it goes right through the Rock of Gibraltar as well, and off the coast here, Morocco, and whether you want to go to Tunisia or Algeria, don't know, not high on my list. But yeah, so if you wanted to see any of those areas, particularly Egypt, perfect opportunity to kill two bucket lists at the same time. The big one for Australia, of course, is 2028, 22nd of July. So we know what the weather will be like in about 4 weeks' time in Sydney, probably much like it's been now. So quite likely to be cloudy. We'll get a partial eclipse about 2 o'clock, roughly 2 o'clock in the afternoon, but I'll probably look at it, but I wouldn't drive to see it. I'd rather drive maybe through here. So this is the greatest eclipse up here. Goes through Sydney, and see Sydney's right in the middle of it, but it's in winter, and if you look at the cloud cover, it's quite clear through here, but once you get down towards Sydney, the possibility of cloud increases quite a bit. So the place to be is up through here. I'm sure Greg has probably already worked out where he's going to set up a tent to see it. Possibly from one horizon to the other, there'll be no one except a constellation of MPAS people or something, I guess, because this one you can drive to. You can drive just right up the middle of Australia to see it. You can set up your telescope and there's no one as far as the eye can see. And it's quite likely zero cloud either. So 2028, the big thing is that it's in Sydney, but Sydney is not the place to be. Central Australia is definitely the better place to be, and I'm sure they'll have information on, well, not cities, towns, that are in a very good position for that eclipse. So then in 2030, you'll see it's not much later. A couple of years later, there's another one, goes just above Adelaide. So if you're just on the edge here of Queensland, so I guess Brisbane's down here, whatever's up here, I think this is Airlie Beach or something here, they just miss out. The sun sets and just before the total comes through. But that one travels again right across parts of Australia which are very, very likely to be clear. And November, so warm. 2038, Boxing Day. This one comes right down across here, virtually anywhere on the Murray. You will see that total eclipse. That one that was off the coast of Western Australia went over this little bit of dirt here. Just this tiny little bit was the only bit that you could be on out of the whole country. So get ready. Plan what you're going to do for the next 10 years or so, or even 6 years takes you out to 2030. And we've got potentially 3 eclipses that you can drive to, each one. And if you want to go to Egypt, then you could go to Egypt. I personally would not go to the one in 2026. I couldn't be bothered. I don't want to see, oh, there's the total eclipse. Oh, it's dark. Yes. So thank you all.
Do we have any questions?
Any questions?
My daughter's actually already organising the one for Spain.
Oh, right, yeah. Yeah, at first I thought we might go, but then when I discovered that it's an hour and a half off sunset. But if you always wanted to see Spain, then it's a good thing, just like Egypt. It's an excellent justification for going to Egypt is to see the total eclipse. Yeah.
And also, what happens to your cruise ship when 4,500 people are standing on one side of the upper deck?
Yeah, I know. They probably have to punt the bilges over to the other side, I guess, to stop it from sort of going, yeah.
I'm sure the captain's looked at that.
Yeah, well, they probably get all the crew to go on the other side. Yeah.
Any other eclipse questions?
I've seen an eclipse. It was about 6 or 7 years ago, Pete. And I was living in Mornington, and I got my telescope outside the shops, and it started about 11 o'clock, and then when it passed about 2 o'clock in the morning, it's just like a golden ball running up the Christmas tree.
That'd definitely be a lunar eclipse if you saw it over night time. Yeah.
I don't know what lunar was, or a lunatic eclipse.
Trevor, the one I saw, the partial I saw at Sandringham, it was probably the Seduna one.
Yeah, there was one in Seduna or something, wasn't there?
Yeah,
that was a few years ago. Yeah.
30 or 40% in Melbourne.
Yeah, I remember that because I had my PST out and I took it down to our strip.
Of the shark tooth,
yeah, I took it to our local strip shopping centre in Bentley and set it up and said, "Oh, you want to have a look at the sun?" No. No one wanted to look. And then, of course, it was on the news and people go, "Oh, you missed that." Yeah.
This is the photo of the shark fin eclipse. That was taken that same time. Yeah, it's probably got the date on it somewhere.
And there's another one that there's some pictures there from me and Ian Sullivan as well at the same eclipse. That was the one that was meant to be Sojourner, but Sojourner was looking too cloudy, so we diverted up to Woomera Way instead, which is inland.
Clear, absolutely.
Oh yeah, Woomera was very clear, very hot and sticky, so probably similar sort of conditions to Mexico.
Oh, some places in Mexico were like 38, 40 degrees, and then like a few weeks later we're here and it's like 3 or 4 degrees. Yeah, big change, but yeah, it was very warm.
The Cairns was also cloudy on the beach, but people further inland saw the totality.
Yeah, with the Cairns one, that was 2012, and I was also on a P&O cruise for that one, and Trevor mentioned earlier that it got to within about 99%, but the ship didn't get to the right spot in time for the shadow, unfortunately. Missed by about one horizon. Didn't quite judge the prevailing currents properly.
Yeah, because you said it, and we're going so fast, the whole ship is going... Yeah, that's sort of flat out.
Yeah, they were going like the clappers, but they didn't quite get there, unfortunately. Okay, well, thanks, Trevor. We look forward to the next one.
66 million years ago, a huge asteroid that hit planet Earth caused one of the biggest extinction events on the planet. But even today, a lot of scientists are still not certain where this particular rock came from. But more importantly, is this going to happen anytime soon once again? Hello wonderful person, this is Anton, and today we're going to be trying to answer a lot of these questions. We're going to figure out where this asteroid probably came from, and we're going to find out when similar such event could also occur on the planet, while also discovering some of the previous events even before this event 66 million years ago. The event that's usually referred to as the KPG extinction event. The one that ended up producing a huge crater known as the Chicxulub. And here a lot of the data is going to be coming from the paper that recently came out that you can find in the description below, that used a lot of computer simulations, a lot of modeling, but also sampled some of the rocks present in the crater itself in order to try to establish the best possible location for these rocks and to establish how frequent these collisions happen on the planet, while also figuring out what exactly caused this asteroid to collide with planet Earth. But let's start right here, with the image you can find in the description below of what's known as the Earth Impact Database. Here you can actually see some of the biggest events that ever occurred on the planet. At least the ones we've found so far. Obviously some of them have never been found either because they're underwater or because they've been covered by sediments for millions and millions of years. Either way, the bigger the circle you see, the more powerful the event. This one right here, the Vredefort crater that we've discussed in one of the previous videos, somewhere right there, is considered to be the biggest to date. It happened roughly around 2 billion years ago. Then, not so far away from where I used to live in Canada, we can actually find one of the biggest craters in the world known as the Sudbury crater. This one also happened about 1.8 billion years ago. But as you can see, from all of the big circles, there's only one more left, and that's the one we're talking about today. The crater that was created by an asteroid probably around 10 to maybe 11 kilometers in diameter, and an asteroid that we've discussed on this channel many times. The previous video, by the way, that should be somewhere right there at some point, talks about the discovery of the tsunami waves that were actually created by this asteroid, and now we know quite a lot about them, including the size of the waves, as the waves were hitting the shores of North America. But out of all of these craters present here, only one of them has been directly connected to an extinction event. The event that we usually relate to the extinction of dinosaurs, even though technically not all dinosaurs perished, some of them turned into birds. Although here a lot of scientists would argue with me saying that birds are dinosaurs, but I disagree. Anyway, more about this later in some of the future videos. So anyway, we know that this event happened, we also know that it caused a major extinction event and changed the climate of the planet quite dramatically, but we also know that it was most likely connected to several other major events which altogether resulted in the major extinction. So it wasn't just the asteroid collision itself, it was actually several events including a major volcanic eruption and including another asteroid a little bit later. But how do you possibly figure out where something came from 66 million years ago, considering the fact that we barely have any information about planet Earth back then? Well, there is a way. There are two ways actually. One of them is by actually looking at the samples collected from the crater itself and figuring out what sort of an asteroid this represents. By doing this, we can then actually figure out what region of the solar system this rock might have come from. This right here is actually from a slightly different study, a study that you can also find in the description below. But in this study, scientists were actually surprised to discover that certain relatively red objects, specifically red asteroid-like objects, such as the ones we usually find in the farthest reaches of the solar system, have also been discovered in the asteroid belt, at least 2 of them. And this implied to the scientists that there's actually a way for various asteroids and for various objects to sort of switch from one orbit to another through various gravitational interactions with various planets. And so here they realized that some of these rocks got shifted to a new orbit. But they've discovered this by looking at the actual compositions of various asteroids. And so here, if we look at the asteroid belt itself, the one that's located between Mars and Jupiter, we will realize that most of the asteroids and most of the rocks present here generally have a somewhat specific composition. We're not actually going to find a lot of these red rocks normally found at the outskirts of the solar system. And at the same time, depending on the region of the asteroid belt, we're going to find more of certain types of rocks compared to others. For example, in certain regions, we're going to find more carbonaceous asteroids, the ones that are relatively dark, the ones that don't actually reflect a lot of light, and for the most part contain a lot of carbon on the surface. Whereas in other parts of the asteroid belt, we're going to find more rocks that are silicate-based or maybe even metallic. And so by knowing the composition of an asteroid, we can generally determine its original orbit to some extent, or even figure out if maybe it was some sort of a comet coming from the farthest reaches, which is also of course a possibility. But then there's also a question of size. If the asteroid is really big and it contains certain materials on the inside, we expect it to be in a very specific position. And then by comparing its composition, its size and the potential orbit, we can even figure out what family it probably came from and if it has any siblings that we can maybe investigate. But more importantly, we can figure out how frequently these collisions might occur in the future. And this is the approach that the scientists took here. First of all, by using analysis from some of the other papers, they established, almost certainly, that the asteroid itself was what's known as the C-type asteroid, also known as the carbonaceous chondrite asteroid, which is essentially a somewhat dark object with a lot of carbon on the surface. And one of the more recent famous examples of this type of an asteroid is the asteroid Ryugu right here that the Japanese Space Agency was able to use to capture a few samples. Although this one here is way smaller than the one that caused the extinction of dinosaurs. And so the combination of studies on rock layers combined with various drill core samples from inside the crater confirmed that the impactor was very similar to these C-type asteroids. But the problem with this discovery is that we don't really know of very many large C-type asteroids that hit planet Earth. And because of this, it was always assumed that these collisions are extremely rare, like maybe once in a billion years or so, possibly even longer than that. At the same time, if we were to investigate the asteroid belt as we currently know it, we're not actually going to find a lot of similar sized rocks that are C-type. Most C-type asteroids are way smaller, with some, very few of them, being extremely large. And the largest one is this one right here, known as Hygeia. But because Hygeia and similar C-type asteroids represent such a tiny part of the asteroid belt itself, the belt that contains roughly around 2 million asteroids over 1 kilometer in size, statistically this doesn't actually add up, it does not really make sense. How could a 10 kilometer C-type asteroid strike planet Earth? Especially if not a lot of them exist in the asteroid belt today. Now once again, there's obviously a lot of C-type asteroids, but most of them are not in that size range, and that's what sort of confused the scientists for many years now. Although, a quick side note, a lot of near-Earth asteroids like Ryugu right here are actually C-type asteroids, and they do come really close to our planet, but once again, none of them are in that 10 kilometer side range. All of them without exception are at least 10 times smaller, and so that's sort of where the mystery lies. Where exactly did this asteroid originally come from? And to try to solve this, they essentially had to employ the NASA's Pleiades supercomputer. They developed a model using 130,000 different asteroids and then ran this simulation trying to see what happens to various types of asteroids over time. And here what they discovered is that over time, because of the interactions with other asteroids, slight gravitational perturbations, and a lot of pressure from the sun itself, something we usually refer to as the Yarkovsky effect, once in a while at least one of these asteroids, very large asteroids, entered what the scientists in this paper refer to as the dynamic escape hatch, which is sort of like a gravitational instability that causes the asteroid to suddenly change its orbit. And when this happens, it can suddenly get propelled to a completely different destination, which is exactly what happened to these two other asteroids that I previously mentioned that ended up traveling from the outskirts of the solar system to the inner solar system, and eventually getting stuck in the orbit here. But once inside this escape hatch position, it has a chance of getting a slight kick from one of the planets, which can then sort of force it to collide with another planet. All of this is sort of related to this other video I made on the channel a few months ago, where the scientists realized that there's actually something called interplanetary superhighway that's formed by various gravitational interactions between planets, and we can technically use this superhighway to easily transfer an object from one planet to another by barely using any fuel at all. But because this is such a dynamic system and because it always changes, it's actually extremely difficult to try to simulate this particular pathway. But because there are millions of asteroids, at least one of them has a chance to occasionally move into the escape hatch and get propelled by planets to smack into something else. And 66 million years ago, that something else was planet Earth. But once the model was ran, the results suggested that a collision between a rock that's about 10 kilometers in size and also carbonaceous in nature, basically similar to the one that destroyed the dinosaurs, should actually happen on planet Earth approximately every 250 million years. Which is really interesting, because first of all, this is good news. It means that we have at least 200 million years to prepare for the next one. While at the same time confirming the event that was discovered a few years ago, the large crater discovered in Australia that was also created by a rock at least 10 kilometers in size, with the event here happening approximately 300 million years ago, or roughly around 250 million years before the event that hit Mexico. Which means that their model sort of makes sense. It does seem to predict the chance for these large 10-kilometer collisions pretty well. But where exactly could this have come from? Was it from the asteroid belt or from some other region in the solar system? Well, in this case, the analysis is based on the size and the composition, and statistically, it could not have come from the same region as these smaller rocks, from the inner asteroid belt. It has to have come from the region on the outskirts of the asteroid belt, where we do find a large amount of different C-type asteroids that are normally anywhere from just a few kilometers across up to about several hundred kilometers across. But unfortunately, we still don't really know which family of asteroids this one belonged to. What we do know is that its orbit was very likely on the outskirts much closer to Jupiter, with the average distance being about 2.5 astronomical units away from the Sun. But luckily for us, maybe sometime next year, we might actually hear more about the potential origins of this asteroid and possibly even find one of its family members, or basically one of the cousins or brothers or sisters that it most likely separated from. And the reason I'm saying this is because of this mission right here that's launching in October of this year, known as Lucy. Lucy is going to be a multi-year mission, and we'll actually talk more about this in some of the future videos, but one of its first destinations is going to be a really interesting, relatively large C-type asteroid known as 52246 Donald Johansen, named after the famous paleontologist who co-discovered Lucy, the fossil of a famous Australopithecus that most likely was one of our ancestors living approximately 3.2 million years ago. And so in the next few years, it's actually going to pass very close to this particular asteroid, and it's going to have a chance to investigate it and to study some of the composition, which might be just enough information for us to figure out if this is indeed one of the potential family members of the dinosaur killer asteroid, and if also, maybe, this is indeed where it actually came from. Although we might not actually know anything about this until maybe 2025-2026, when the flyby occurs and when we actually get to take some of the photos. But so anyway, a pretty interesting analysis, and of course a really important peace of mind when it comes to these large rocks possibly destroying planet Earth. It does look like we still have approximately 200 million years before next such collision occurs. But when it comes to small rocks, the collision with these happens much more frequently. As a matter of fact, anything that's approximately 1 kilometer in size does have a chance to collide with planet Earth every 500,000 years or so. So we still need to find technologies and find ways to try to divert these asteroids if we find one on a collision path, just to make sure we don't actually end up like these guys. And today we're going to be talking about several topics that I've been fascinated with since I was really young. The asteroid that led to the demise of dinosaurs, combined with the idea behind the tsunami that it created, and more specifically, a megatsunami. And today we're going to discuss this new research that came out not so long ago, that actually discovered some really unusual formations on the bottom of the ocean that was very likely produced by the megatsunami that was created by this asteroid. Something that you sort of see right here in this image, but I'm going to be explaining what exactly you're looking at right here in a few minutes. First of all, we know that the asteroid that collided with the planet 66 million years ago did not just create a tsunami, it had a lot of different effects. Effects that we're still learning about even today. First of all, the debris from the explosion spread around the planet and ended up creating a lot of different wildfires in many different ancient forests. It's actually believed that about 75% of all of the forests burned down within only a few weeks after this. It also released a tremendous amount of various sediments from the seafloor where the asteroid hit the planet, and this ended up acidifying the oceans within only a few weeks as well. The acidity of the oceans increased so much that it actually led to the demise of many different ocean organisms. Something that is actually happening today as well, but for a slightly different reason. And then there were also obvious atmospheric effects such as dust storms and just the overall increase in dust in the air, which lowered the temperature of the planet for at least a few decades, which eventually led to the demise of most of the dinosaurs. But because the asteroid hit the ocean near the Yucatan Peninsula in Mexico, this also naturally created an extremely large tsunami. But not a regular tsunami, not a type of a tsunami we've heard about back in 2004, or the one from Japan in 2011. These types of waves are slightly different and are produced in a very different way as well. Instead, what it created was known as a megatsunami, and this is an entirely different concept despite a similarity in a name. Megatsunamis have happened on the planet for different reasons as well, with the most recent one happening in 2015 in Alaska, but we normally don't get any footage of them. And there's also almost no way to predict them or to catch them in the act. They're very sudden, they're extremely quick, and they are extremely destructive. So first, a regular tsunami. Let's watch this video that explains how all of this works. Both of the tsunamis in 2004 and 2011 were a result of some sort of a seismological activity and also were a result of an earthquake. In this case, a displacement by the tectonic plate sort of lifts the layer of the water here and creates a somewhat small but very fast moving wave across the open ocean. Normally these waves are actually almost invisible unless of course you know what you're looking for. But as they approach the shore and as they get closer and closer to land, they experience a sudden slowdown in their velocity, but also a sudden increase in their height. And normally they also come as a kind of a tsunami train, as you see right here. And this is what happened in Southeast Asia in 2004 and in Japan in 2011. And so as the wave starts approaching the land, the recession of the ocean right here indicates that a large amount of water is about to strike the land. Now this doesn't really happen right away, it usually takes at least a few minutes, possibly even half an hour, but eventually you'll notice how this sudden surge starts to approach the land itself. It's not really a very large wave, sometimes it's really only a few meters in height, but it's a huge amount of water and it's a sudden surge that just keeps coming and coming and coming. Now that's literally what we call a tsunami. And this is exactly what happened both in Japan and in countries like Indonesia. Now this is a very destructive event, but it's not destructive because the wave is tall or because the water is moving fast. It's destructive because there's so much water just that keeps coming and coming and coming. And this can actually last for hours and sometimes even last for many hours. And in some cases it actually repeats several times because of the idea of that tsunami train I showed you previously. But a megatsunami is something almost entirely different. Here's an example from 1958 from Alaska, probably the most famous megatsunami known, because this one was actually witnessed and survived by two people fishing in this area known as the Lituya Bay, located right here in Alaska. And this particular bay is sort of the epicenter for many of these unusual phenomena known as Megatsunami. It has happened in the past before that. There are actually several amazing videos created by Dr. Stephen Ward, whose channel you can find in the description below, that explain all of this visually by using these brilliant simulations. So here's how a typical megatsunami is created. It's normally related to a sudden collapse of a large amount of ground or some sort of an underground mudslide, or in some cases a very large asteroid suddenly striking in the middle of the ocean. This sudden increase in volume essentially creates something that looks like this. It pushes the water so much that there's suddenly this huge wave that starts moving across, with some waves going as high as 1 kilometer in height, and all of these waves, as you can probably imagine, are extremely destructive. And unlike a typical tsunami here, it's going to be extremely tall, extremely large, even in the open ocean. So here's, for example, one such event from the Cape Verde Islands located in the Atlantic Ocean. Notice how the height of the tsunami here, striking the island, is basically close to 500 meters in height, or over 1640 feet in height, and that is a huge wave. And so something like this happened in Alaska, and this is probably the most well-known event, but a lot of these happened in the last few decades as well. We'll actually talk more about megatsunamis in one of the future videos in a lot more detail, so obviously make sure to subscribe not to miss this video, but some of the most powerful and most destructive ones have always happened either in Alaska or close to the coast of Norway. But going back to the original impact that destroyed the dinosaurs, let's watch the simulation by Stephen Ward of what it was probably like 65 to 66 million years ago when the asteroid hit the planet. And so in this particular case, we know that it most likely happened somewhere right here, and this created a really large but not super large megatsunami. In this case, mostly because it was actually hitting shallow waters, with the highest peak of the wave itself very likely being less than 300 meters in height. And the waves reaching the North American shore were probably around 20 to 30 meters in height as well, so not as dramatic as we originally thought, 1.5 kilometers in height, simply because the water where the asteroid hit was not actually that deep to begin with. But one thing about the tsunami is quite certain: it definitely happened. There are actual signs of deposits coming from various regions around the ocean that were actually discovered as far away as northern US in some of the regions we'll discuss in one of the previous videos. You can find this video somewhere right there. But over the years, more and more clues about the tsunami have actually been discovered through other unrelated studies. And this is one such study. So this is something that was not actually even studying tsunamis or even doing any scientific research. All of this data was collected by the petroleum industry that's basically been kind of mapping the ocean floor, trying to discover more oil deposits somewhere underneath the ground. But 65 million years ago, a big part of the southern US was essentially underwater, including Florida, including parts of Texas, and including, of course, Louisiana. And a lot of this data came from the central Louisiana, where the petroleum industry was basically mapping the ground. And at a depth of approximately 1.5 kilometers, they discovered these unusual ripples, the ones you can kind of see right here, that have clearly been preserved in there for millions and millions of years. Now, normally these ripples are generated by waves, and you've probably seen these in the ocean. This is sort of the example right here. Notice how there are ripples that are actually created by the water waves. But in order for these ripples to be preserved for millions of years, some kind of a major event had to occur in order for these ripples not to be disturbed for millions of years. Such as, for example, if a tsunami wave created these ripples, and then the water in this region was too deep for anything else to disturb it for millions of years afterwards. And so these mega ripples very likely were just preserved by the sediment that deposited in the depth of the ocean and eventually solidified as these ripples we see in this image. But interestingly, originally they did not actually know where these came from. In order to figure this out, they had to sort of trace back the origin of these waves by trying to look where they possibly came from, where the waves came from. And once they traced back the origin of the potential wave, it led them to the site of the original impact 66 million years ago. Now, in terms of the actual properties, these mega ripples seem to have a wavelength of approximately 600 meters, which is of course the distance between the two wave crests right here, with the average height of the wave being about 16 meters or so. So obviously not the 1500 meters that was originally assumed by some of the other studies, but actually almost directly matching the simulations from Stephen Ward. with the tsunami itself very likely continuing for possibly hours or possibly even several days, with these ripples in particular representing huge 16-meter waves hitting the relatively shallow shelf near the Louisiana shore and doing so for many hours. Something that very likely also led to the tremendous amount of sediments being deposited in this particular region, which means that if one day we somehow are able to retrieve samples from here, we might be able to discover some really cool sediments and possibly even actual specimens of ancient wildlife that resided in the area. But I guess for now that's kind of all I wanted to mention. It's a pretty cool discovery. It's an amazing confirmation that a tsunami, or actually a megatsunami, was created by the collision that happened approximately 66 million years ago. But more importantly, it helps us understand how these tremendously powerful collisions affect the planet when they do occur. Now in some of the future videos we'll talk more about various collisions. We'll also discuss the idea of megatsunamis, but for now that's all I wanted to mention. Check out the paper in the description below, as well as Dr. Ward's site and his channel, where he explores various really cool tsunamis and simulates them using advanced techniques.
A 60-meter tsunami is, it wouldn't leave much of the peninsula region if one came this way. Pretty amazing. Okay, now to close, we'll take a ride into a black hole. This is was released only a few weeks ago by NASA's Goddard Space Flight Center. And a couple of things to notice in the video. On the left-hand side, they'll show an external time outside the black hole, and also the time of yourself diving into the black hole. So you can compare the relative time, and you'll actually see the age of the universe go by as you fall in a matter of microseconds, because as you fall into a black hole, from an outside observer, your time slows right down almost to the point of stopping. From your point of view, you just keep falling in. So from your viewpoint looking outwards, you'll see the entire age of the universe go by in the microseconds that you've got left before you actually hit the singularity, which you'll see as we'll go through. to do is fall into a supermassive black hole, and you'll experience the rest of the universe for the microsecond that you've got left. But you will experience it. And with that, I'll close the meeting, and hopefully we'll see you at the July meeting. Thanks.